Hello everyone, I am Vikas Billa and I am from EC department. Now I am going to tell about genetic algorithm method and its applications. So let's get started. So today I am going to tell about genetic algorithm method and use it to antenna parameter optimization. So first of all, what is genetic algorithm method? So generally, genetic algorithm method is inspired from biological evolution process, and it generally mimics the Darwinian theory of survival of fittest in nature. So there are some of technical words like chromosomes, selection, crossover, mutation, and fitness function computation. They are the key elements of genetic algorithm method. Here, genetic selection, crossover, mutation. There are the key operators in the genetic algorithm method. So now we will discuss about the methodology of genetic algorithm method. So this is the fitness flowchart of the genetic algorithm method. So initially we have to choose a fitness function and we'll do initialization. Initialization is nothing but generating a population and encoding it into binary data, and we will do several operations like selection, operation, crossover operation, and mutation operation, and then we will do survivor selection. If the survivor criteria is met, then we will end the method. If the survival criteria doesn't met, it will again undergo termination, and it will enter into the next generation, and same process continues until we will get the survivor criteria will be met. So first of all, what is initialization? So initialization is nothing but we have to start off with a population of individuals where each individual is a solution, and we have each solution is represented with a set of genes where each gene is a solution of variable within the model. Uh, During initialization, we will find the fitness values too, and we will make sure that the population size is not too low or not too high. If the population size is too low, it is very hard to explore the entire space of the problem. If it is too large, it will take so much time to process at each generation, so it will be a drawback. And we have to make sure that the population will be widespread among the given range. If the population we take is very near, it may converge to a local minima, which we generally call it as a premature convergence. So we'll make sure that the population is distant and widespread among the given range values. So so first of all, we will next we will discuss about the selection operator. Selection operator is nothing but uh, previously we had found out that the fitness values of a random population, right? In during initialization process, in selection, what we will do is that we will find the most fittest individuals and we will eliminate the weakest ones. And for selection, there are different ways. Some of them are fitness proportion selection, rank based selection, and tournament selection. So we'll go to the next one. This next one is crossover operation. In crossover operation, we will gene of uh, two random genes, and we will do crossover at some random point, like fourth position or fifth position or first position, based on our we will do it randomly. So there are uh, many types of crossovers. Some of them are first point crossover, endpoint crossover, and uniform crossover. And next one is mutation. In mutation, we'll randomly select some positions at zeros in a genes, and we will randomly change the values at from zeros to 1 or 1 to 0. There are again some types of mutations like insert mutation, swab mutation, and inversion mutation, and scramble mutation. And finally, we'll We already know that about survivor selection. In survivor selection, we generally find out the fitness of the given population. If the survivor criteria is met, we will stop here. If the survival criteria doesn't met, then we will undergo termination, and the the process will run until the survival criteria met. More number of generations, the best solution will be obtained. So it's nothing but the it's evolution. So this is the warrior of operators in the genetic algorithm method. Selection, crossover, mutation, they are the key operators in the genetic algorithm method. So there are few types of selection here: roll free selection, rank selection, tournament selection, Boltzmann selection. Roll wheel selection is nothing but it is spinning off a wheel, so that the most probable one get has the highest fittest one get the most probability to get selected. And rank selection is nothing but giving ranks to the highest fitness values from to lowest fitness values. And the tournament selection is nothing but taking a set of population, and we'll put in like in a tournament we'll put a knockout matches between them, and the fittest population will be survived. In crossover, and then crossover operators too, there are four types. So in a single point crossover, we'll do crossover at single point. In k point crossover, we'll do crossover operation at k points. And in uniform crossover, we will do crossover at every point. In partially mapped crossover, only few points we will do crossover. In mutation also, there are four types: displacement mutation, inversion mutation, reversing mutation, and bit flipping mutation. So they are nothing but based on some criteria, like mm, the ones and zeros are selected, and the values changes from zeros to ones and ones to zeros. So we'll take an example. So assuming that a genetic algorithm is used to optimize the function f of x equal to x square minus 4x plus 3, what is the value of the function at the optimal solution after one generation of the algorithm with a population size of 50 and a mutation rate of 0.05? So you have to note that for if in question it is given that optimal solution, we will select, we'll generally find out the maximum value. So you know the steps, right? So first one is initialization. Initialization is nothing but generating a random population, and we will convert them into binary values and find out the fitness value of the respective population. And we will do parental selection based on the probability of the string being selected. So here I had taken random values like 13, 25, 19, 30, 34, and I had find out the uh, binary values for the respective uh, numerical populations. And this is what I call it genes or chromosomes in the next steps. So we know the first step and next step, right? Selection, parent selection. So in parent selection, we had found out fitness values from the given population, and we had found out the probability of string being selected from for each chromosome. So and we will wrote the expected count. Here we had observed that 34 has the high expected count, that is, it is the highest probability of being selected, and 13 has the lowest expected count, sorry, uh, which is which has less probability to being selected. That means it is the weakest among the given population, so it will be eliminated from the table, and the remaining chromosomes will be sent to the mating pool. So in mating pool, the weakest among the given population will be replaced with the strongest one, and we do crossover operation. So I had did at a fourth position for one two strings, and I did uh, at third for three four strings. I did crossover at third position. So these are the final offsprings after crossover. So if I had found the that x value, that means the new offsprings population and the fitness values, we will observe that the total fitness value will get increased. And now we will do mutation operation. We know that mutation operation is nothing but random bits are selected randomly, and we will be changed from 0 to 1 and 1 to 0. So here I had changed some values. And if you found out that x values and fitness values, the final output will be greater than the initial value. So here, in the question I had taken that for what is the value function at optimal solution after one generation. So I had did only for one generation. If it is given that 10 generation, we have to uh, do this selector operators like selection, crossover, mutation for 10 generations. And in general, if the selection criteria is not met, we will do termination. That is nothing but repeat the process until that the population will converges to the optimal solution. So now I'm going to discuss about antenna parameter optimization using genetic algorithm method. So in this antenna parameter optimization, I generally taken a microstrip patch antenna, and I am going to find the fit optimize based on the parameters like bandwidth and VSW, like width. It's actually width. Uh, so I'm going to explain it in a code, so it will be much easier to understand. So this is the code for antenna parameter optimization. So initially taken I had taken for math operations. Initially I had taken some random modules, and initially I had wrote for fitness function and based on the input values. So this here I had taken the mm, fitness function, and where BW is the bandwidth and W is the width of the microstrip patch antenna. These are the two parameters that I am going to optimize. So these are the formulas like S where S11 will be the reflection coefficient, Zn and Zc were the characteristic impedance and input impedance, and K will be the wave number, etc. And then I had wrote in a genetic algorithm function with the selection operators and crossover mutation operators. So initially I had taken variables like fitness function, number of generation, population size, mutation rate, and number of parents. So this uh, this this random function generally takes random values from the given range. And then so here I had find out the fitness of each individual. And so this is the selection operator that is that selects the inputs value final values, and sends them to the mating pool. And this is the cross spring operation, crossover operation. In this operation, generally we had taken two parents and randomly, and we will do crossover operation at single points. And finally we will know about the mutation offspring. In this mutation offspring, we generally uh, take random values at zero at random points and converts them from 0 to 1s and 1 to zeros. So and finally we had written the fitness values and fitness individual and uh, fitness final fitness values. So here I had actually given input parameters. If you want to like give an input from take an input, then here we will write int of input for a number of generations. And finally, I had plot uh, x comma y labels, where uh, x label is the number of generations and y label will be the number of fitness. So this is the fitness value after I got after actually 50 generations, and population size is 100. And the fittest value will be this one. So this is all about genetic algorithm method. So thank you very much.